everyone. We are back for the last topic in series. Now I'm going to split this video into two parts. The first part will be the kind of theory learning part of it, and then for the second part I'll do some examples, as otherwise I think it'll be too long of a video. All right, so far your flowchart should be completely filled out. We know all of the tests we're going to learn. In this section, we're going to start looking at series that have X in them. So far, every series we've looked at has only had an N in it, and the question has been, does it either diverge or converge? Which is it, right? And if it diverges, we still check for conditional convergence, right? So we have this whole, like, what does this series do? Does it converge conditionally? Does it converge absolutely? Or does it diverge? When X enters the series, that becomes a more complicated question to answer. Now we're going to go through the same process that we did before by using our tests. But now remember that the value of our terms doesn't just depend on your N value, it also depends on X. So we have to take a look at, well, what can X be? Right? We're going to be looking at intervals of convergence here. We're going to be saying, okay, this thing will converge if X is on this interval, right? And we already done this with geometrics, right? We said, okay, this series is geometric. It'll converge as long as R is between -1 and 1. It'll converge absolutely, right? We've done that. Now we have to be able to do that for series that aren't geometric. Okay, so when you are looking at a series and you're determining its interval of convergence, there are three possibilities, and only three possibilities. The first possibility is that the series converges no matter what X is. If that's the case, our interval of convergence would be -infinity all the way to infinity. We're saying, look, this series is going to converge. I don't care how big or small X is. An example of that is this one here, the series X over N factorial. Factorial growth is the fastest of fastest growths. So regardless of what this X is, it could be a gazillion. Eventually, these terms are going to go to zero and it's going to converge, right? We could prove that, but why should we? All right. The second thing that can happen is that the series is just a mess and it's going to diverge no matter what. Right? This series right here, these terms are getting bigger. Right? N is getting bigger and it's being multiplied by X. I don't care what X is. These terms are getting bigger. That's going to diverge. The most common thing, though, that's going to happen is that it's going to converge, but it's going to converge on some finite interval. Okay. And so here's an example of this. We know this is geometric, right? X to the N. This will converge as long as X is between -1 and 1. So there's this condition like, okay, well, it'll converge, but only if. This is probably the most likely to happen, and this is the one that we have to look at the closest. Okay, so let's talk a little bit about interval of convergence. So when we talk about interval of convergence, we're talking about the X values for which the series will converge. What X values could I plug in to that polynomial and have it still be valid? And again, we've looked at this multiple times with geometrics. You look at the graph and you see that function, that polynomial is hugging the curve perfectly, and then all of a sudden it goes haywire, right? That's because we've left the interval of convergence. And we know the interval of convergence is always going to be symmetrical around the center. Again, with geometrics, if it's centered at 0, my interval of convergence is always going to be between -1 and 1. Right? If it's centered at 2, my interval of convergence will be between 1 and 3, because we know for geometrics that it's got to be that within 1. Right? Obviously, for other ones, it's not going to be like that. So just a little bit of kind of vocabulary before we move on, so we know what we're talking about here. Okay, we've got this, there's a whole number line, and we've got this one little interval of convergence. Notice A, our center, is the middle of it. All right. The radius of convergence is simply the distance between the center and the end of the interval. Okay? The radius of convergence doesn't tell us anything about where the center is. It just tells us how far from the center we can go. So, for example, for a geometric, any geometric, well, that's not true. I guess it depends on what your R value is. But for our series x to the n, my radius of convergence is 1. That means I can go 1 to the right of the series or center, or 1 to the left of the center. If your radius of convergence is 10, that means you can go 10 to the right of the center and 10 to the left of the center. Okay. Now, if I know my center, I can use my interval of convergence to get my interval of convergence, right? Because if I know my center, all I have to do to get my interval is go back and forward with my radius of convergence. So if this is 0 and my radius of convergence is 5, then this is going to be -5 to 5. If this is 10 and my radius of convergence is 5, then this is going to be 5 to 15. Right? My center, and we're saying, oh, I can move 5 to either side. Okay, so there's only 2 ways to know the radius of convergence. If they are asking you for the radius of convergence, it is either geometric, in which case you're setting your R value less than between -1 and 1, or you're supposed to be using the ratio test. Because the ratio test is the only test that will allow you to see the radius of convergence. All of the other tests will say converge or diverge. Those are only going to work if your answer is straight, this always converges or this always diverges. If you need a radius or an interval of convergence, the ratio test is the only possible place you can find it. So when they ask you either for a radius of convergence or an interval of convergence, when they ask you where, for what x values will this series converge, or for what x values can we use this series to approximate such a function, first things first, check if it's geometric. Because if it's geometric, it's a real easy question to answer. Take that R value, make sure it's between -1 and 1. That's your interval. Okay. If it's not geometric, the first place we go is the ratio test. It's the only one that's going to work for us. Okay, now, we know that when we use the ratio test, that we can go from, once we get our interval of convergence, we might say, okay, we can go from -1 to 1. So here's a series, right? X to the 3n over n, and we know that this is going to converge, because I already did the work for us, between -1 and 1. So let's say we do the ratio test, we plow through, we find out that it goes from -1 to 1. Okay, the ratio test proves absolute convergence. So I know that this series will converge absolutely between -1 and 1. What I don't know, though, is if I can include -1 or 1 in my interval. Those endpoints, can I include those in my interval? And those endpoints, the way we answer that question is by testing those endpoints individually. And I'll show you what I mean here in a minute. The ratio test is going to give you an interval of absolute convergence. That is an open interval. Our job next then is to test those endpoints individually and see, can we include them? Here's what I mean. If I know my series x to the 3n over n converges on -1 to 1, all I'm going to do is I'm going to say, okay, well, my interval of convergence right now is -1 open to 1 open, right? Whoops. The question is, can I fill these dots in? I know that all of this in between is absolute convergence. The question is, can I include the -1 in that? Can I include the 1 in that? So let's look. What happens when you plug in a -1? So literally, what does this series become when x is -1? When I plug in a -1 for x, in other words, now look what I have. I have a series like we're used to looking at that doesn't have any x's in it, right? So when I plug in a -1 for x, I get an alternating -1, +1, negative, positive, negative, positive, negative, positive, and a 1 over n. The question is, does this converge? Well, let's see. I have alternating. So let's see, my first term is -1, and then plus 1/2 minus 1/3 plus 1/5 minus 1/6. Hey, I recognize that guy. Right? This could just as easily be a -1 to the n. And if this is -1 to the n, it's just alternating. This is an alternating harmonic series. Well, we know something about the alternating harmonic series, right? This series converges, but it only converges conditionally. If I take its absolute value, I don't have convergence. Okay? So what's happening at -1? It's converging conditionally. I'm going to color this in, but I'm only going to do like a, because it's conditional. Okay, let's see what happens at 1. Okay. What happens on the other end? Can I plug in 1? When I take my series and I plug in 1, I get 1 to the 3n over n. So I get the series 1 over n. That's the harmonic, and it diverges. So I cannot use this point. So when I look at my interval, if they say, where does this thing converge? We can say it converges on -1 to 1. I can include the -1 because it converges conditionally there. I cannot include the 1. Okay. A lot of times they ask this question in three parts. They say, where does it converge absolutely? Where does it converge conditionally? And then where does it converge? So if they say, where does it converge absolutely? Well, the only place that happens is -1 to 1, not including. Where does it converge conditionally? Well, that's only at one single point. It converges conditionally at x equals -1. If you put those two together, that's your, in general, interval of convergence. So sometimes you will see that question asked in 3 parts, and when we do some practice problems in the next video, we will do that. We'll answer all 3 of those parts. Okay, but this is the general idea of testing those endpoints. So in the next video, we're going to do some practice problems where we start with a series, use the ratio test to find the interval, and then test those endpoints. Okay? We're pretty good at using the ratio test, so this isn't usually that big of a deal. Okay, I will see you then. Put any questions that you have in the end of the video.